Hi everyone. Today's lecture is on exception handling. So pretty much these errors that come up and when you compile and input a wrong value and stuff. I'm sure that you've all seen them, but there is a way to handle them, and we'll see how to do that in this lecture. So let me click here, and yeah, okay. Right. So what are exceptions? Handling exceptions. The system.exception class. Exceptions hierarchy, throwing exceptions, and best practices. Normally, it's a fairly simple and fairly short lecture. This one, and the reason that we don't start with object-oriented programming straight away is because we need to use exceptions in it in some places, and you would need to know what those are and how to use them, or at least just a couple of basic things. Nothing that special. So yeah, what are exceptions? Exceptions in .NET are classic implementation of the object-oriented programming exception module. So what does that thing mean? It means that contrary to this second thing here, you have a class of exceptions, and they're separated in different types. Okay, rather than just typing something like if I don't know, if if name.length is less than 2, write your name should be bigger or something like that, or just throw an error number 505, and you would have no idea what that is. You have to search for it in Google documentations and so on. This actually provides you a nice way and very descriptive way of what exactly happened with your program, because if I see error 732, I have no idea what this thing is, and yeah, and then I have to search for it and so on. With the object-oriented programming exception model, which is implemented in .NET, you wouldn't have to worry about that, because the errors, have a text, have a stack trace, and so on. So all of the needed things for you to understand where it came from and so on. So pretty much everything here is explained. Simplify code construction and maintenance. So if I have to do it with with cases, if this input is wrong, print that. If this input is wrong, print that, and so on. This is a lot easier to handle and to see and to change and so on. You can even make your own exceptions, which is something that we won't be doing in this lecture, but it's fairly simple once we go through that course. But yeah, for now we'll just use the ones that are built in. Okay, allow the problematic situations to be processed at multiple levels as well. So you can process an error not only in the place or in the method where it actually appears. You can process it in many ways, in many different methods and so on. They don't have to be in the same place, which is also a big bonus, but you will understand what that is when I get there. Okay, so handling exceptions, we have the try-catch blocks and the try-catch finally blocks. And exceptions are like Pokemon, gotta catch them all. So yeah, pretty much that. So let's open up Visual Studio. Let me just open up Zoom it as well while I'm at it. So Zoom it, there it is. And let's see what these things are, and how do we handle them and so on. Right, so let me make a new project. I should probably start putting them in different folders, but it's not gonna be today. Okay, so this thing, number 2 here, I don't know if you see it, but this means that I created console application 1, which is really bad. So yeah, I'll try not to do that. So exception handling demo. All right. Okay, so the first one I would like to change the name of to try catch finally, and I'll put that here as well. Probably zoom in a little bit as well. Yes. delete all of that. And right, so who can tell me a quick and very efficient way of getting an exception? Out of bounds array. Okay, maybe something simpler. I can do that as well. Sorry? I can throw an exception, but I want to actually, get some action which causes an error. So Stack Overflow, I would have to explain what recursion is well. Let's try. Okay, so something with the parsing. Okay. All right. So let's do that. So int dot parse, and let's say rank here. Semicolon. Yes, it's been 2 weeks, so I have to remind myself of doing that. Okay, so this is no, actually, yeah. Well, when I think when you type JavaScript, the browser puts them automatically for you in some places, and yeah, you can get away with it. But yeah, anyways. All right, so yeah, this is an exception. So it's not good. This means that something went wrong. Someone didn't do their jobs as developers, and we get an exception like this. So let me just try and make this a little bit bigger, zoom in, and let's see what happens. So alright, so okay, this is system.formatException. So we know that they're in the system library. Okay, input string was not in the correct format. Okay, clearly when we try to parse a number and we actually parse a string which is not a number, clearly this is a format exception. And right, so what else do we see? We have here some more information. We have the path to the file, and also we have the line 9. So we have the file, we have the line. We can easily see where we are wrong in this case. So yeah, so this is line 9, and right now we are going to be doing something different. So let me just do something else real quick. So let me put int number equals int dot parse console dot read line, and that thing here as well. And yeah, so if I do that same thing now and I put some text, I'm gonna get the same thing as well. So yeah, so how do we avoid that? How do we check if we've actually put something? How do we want to handle it, and so on? So try and then tap, and pretty much generates all that you need to know and remember. So it's exactly as it says. So I wanna try some code in here, and if there is any exception, so catch exception, then I want to do something else in here, maybe put an error message or something like that. So let's see. Let's have here I don't know, console write line, and let's say you should input a number. Okay, let's try that. And if I put something up, if I put something else, and we see you should input a number. And the main thing about this is that I can actually execute something which is after that. So my program doesn't stop, your game doesn't stop. I can actually make something with it after that. So if I here say console.writeLine, and here I want to say this is executed after the block. Okay, so let's say that I actually input a number 2. Okay, we get this, and if I put something else, this is also executed after the block. Okay, you can catch different types of exceptions, but right now I don't even need this, because when I say catch exception means that I catch all of the exceptions available, and there are actually quite a few different types. So if I just want to say catch exception, then I don't need to write it, and it's gonna work the same way. So yeah, Okay. But normally you would like to catch some specific exceptions. It's never a good practice to just just catch all of them with a random message, which is something like error here. It doesn't really make sense, and it's not very descriptive as well. So what do we do? So we want to catch only the format exception here, and we are gonna say the the variable that we try to assign is of type int, something like that. So let's see if I put something. Okay, and this is again executed. But what happens if I actually get another exception which I haven't caught? Is this line gonna be executed? Probably not. So can you tell me another exception that I can put right now which I haven't caught? Bigger number. Okay, so let's put a bigger number, and we still get the exception here. So everything stopped working, and you see that this line in the end is not executed. So if we want to make it properly, we would have to check what this exception is. In this case, it's system overflow exception. Since I have the system put on top, I don't have to specify it this way. I can just say catch, and here I would like to specify overflow exception, and here I would like to say the number is too big to fit int. Okay, and now if I do all of them, yes, semicolon. Again, it's gonna take me a while. Right, so let's see. Put some text. It's fine. It's executed. Then some big number, and we see this error again, which is very descriptive. It's specific. You know what happens and what you should be doing after that. So yeah, imagine that you have different classes and a whole structure like a game, and you get an error and you have no idea what it is. So yeah, this is the point here. You have to predict, or just by trial and error, see what kind of exceptions you can get, and yeah, that's pretty much it. Okay, so right, what happens though if we really want something to be executed? Because when I write code like this, I cannot guarantee myself that there are not going to be any exceptions that I haven't thought of. Okay, maybe I want to have another structure which another block which is called finally, which is going to be always executed. So in here I can say this is always executed, independently of whether we get an exception or not, independently on of whether we caught all of the possible exceptions and so on. So right, so let me just comment that here so that we can make an overflow exception for me to show you that it's always executed. So let me put a text first. Okay, this is always executed, it's there, and now if I put some really big number and I cancel this is always executed, right? And this is the point. So this try catch finally block is not very commonly used, but sometimes you might wanna be sure, even if you have some errors and so on, you would like to clean the RAM or do some cleanup of objects and stuff like that. So you can do that in the try catch finally block. I haven't had the need to use the finally block, but depends on the situation. Maybe you would need to do so in a while. So what else do I have to show? Right. I wanted to show you something else as well. So, all right. So let's let's do something else. Let's do int result equals. What is going to happen if I do something like 5 divided by 0 here? I can't divide by 0 error. Is that going to be when I compile or while it runs? So is it going to be an exception or an error in the error block? Okay, it's going to be an error, I think. Let's see. Yeah. Okay. But if I actually make this, number here, the program has to start. I first have to input a number, and then it's gonna see what's gonna happen. So here, if I put 0, there is no way for the program to tell this at compile time. So let's just do that. So if I put 0 here, I'm gonna get another exception, which is system divide by 0 exception, which is very, very clear what happens. We see where it happened and so on. All right, so so let's do something else. So let's extract this into a. Let's extract both of these into a method. Control RM. Was it? How did I? 1 second. So refactor, extract my control RM. I did press that. So I don't know, read input. Apply. Let me go down here, and I want to make this into a method as well. Let's try that again. So control RM works. And here I want to say maybe divide, not divide. I would like to mention. So divide number. Apply, and now if I make the same error and I put 0, you'll see that there are a lot more lines here. So let me just make that and zoom in a bit. So this is called a stack trace, and it pretty much travels through all of the methods, all of the calls in the stack of any method that I call, and it tells you exactly where the line came. So okay, so we see line 37 and then 32 and then 11. The error appeared on those lines. So let's see, 37, 32, and 11. So 11 is the first call of the method. Then we have 37 is this call of the method, and then we have this 32. So this way is very, very useful, because if you have a large architecture of classes and so on, you can easily trace where the problem comes from, right? Because this is very, very detailed, and it tells you exactly which method calls which and what's happened and so on. So even here I can see the name of my method. So this is read input, and I have divide number as well and so on. It tells me the folder, the file, the line and so on. So pretty much everything that you need to use. Okay. What else? And of course, since I'm dividing by 0, I would like to catch this as well. So I'll just put it here. Here, catch, and then I would like to have divide by 0 exception. And inside here, I would like to say you cannot divide by 0. You have broken maths, and you suck, of course. So now if I put that 0, the program runs. This line here runs as well, even though it's not in the finally block, and everything runs smooth. All right. Any questions here? Everything is fine, fairly simple.
If we want to input another number different from 0 from different.
Okay, what number do you want to input?
Now if we first input the 0 to say the user to input another number again.
Your question will be answered a bit later in the lecture, but I'll say that again. So normally you don't use exceptions the way that I'm showing it now. So you don't use exceptions for user input. For example, if you're on a website and you have to have a username which is at least 2 characters long, then you would do it with ifs. Okay, so if it's actually less than that, then delete the field and go back on the same page or something like that, or just reload or something like that. So exceptions are normally used internally in your classes when you do constructors, when you have properties that you need to validate and so on. But right now I'm just showing you how it's done, and in one of the next lectures we will actually see where is that used in the classes in the object-oriented programming. But normally you don't use it the way that I just use it now. Okay, this is just to show you now how it works, how you catch exceptions and so on. One more thing that I want to add here is that, okay, so I think that I've caught all of the exceptions that I think can happen in my code, which is this method here. And after that, I may still want to make sure that my program doesn't stop. Okay, so maybe in the end I would still need to put catch exception, which is the father of all exceptions, and I may need to say something like some generic error, but that's only after generic error, but that's only after I've considered all of the other cases and so on. Normally you wouldn't need to have this if you're thorough enough in the exceptions that can arise from your application. All right. What else? I can't think of anything else. So yeah, please just bear in mind that I am handling the errors here, or the exceptions, in a different place from where they arise. Okay, so I can have long classes and big architecture, and I can have a very separate place from where my code is to try and catch the exceptions, just to handle them. Okay, right, so let's just move on. All right, this I have no idea why is it like that, so let me just I guess 24 is fine. Right. Okay, the system.exception class. So as I said, all of the exceptions are objects. So I think I mentioned this in the last course, but everything in C# is an object. So this is the most abstract structure in .NET. So exceptions are no exception to this, and they're objects as well. Okay, and the very base exception class is called system.exception, and every one that we saw are argument out of range, Stack Overflow, what else was that? What else was there? What did we just do? FormatException, divide by zero exception. So all of that, they are they inherit from the base class, which is in the exception. So they're like different types. Okay, and each exception contains some information for the error. So I didn't show this, but I'll show it now. So every exception has a message, which is text description of it, and it has a stack trace, something that we saw and I briefly explained to you as well, and have inner exception. So exceptions can be chained, so once you get one you can throw another one and so on, and this inner exception is something that allows you to access those inner exceptions that are thrown after the original one. So we won't deal with that one too much, but I would just like to check those two and see what they do and how are they used. So Here is the exceptions hierarchy that I mentioned. So on top we have the object, we have the base exception, and after that we have application exception. So this is something specifically that you write. So something like bunny validation, bunny name validation or something like that. If you're into banking, then something there as well. I mean, with the accounts, deposits, and so on. So this is something that you write by yourself. It's not hard. We'll explain briefly in one of the next lectures how to do that. It's nothing special to make your own exception. Okay, and then we have this base class. I know that there is a repetition because this is system dot exception dot system exception, but that's how it's done because there are two types here. Okay, we have this IO exception as well, but it's not that interesting. So let's just consider the system exception. So they're into different groups. So we have arithmetic ones. Divide by zero, we have overflow exception, the ones that we just checked. We can also have argument exceptions, so argument out of range. So when you were doing your games, probably you got that a lot from your arrays, or was it argument out of range, or was it index was outside of bounds? Okay, so something similar as well. Okay, we have our argument no, and so on. We have it's quite a big hierarchy, very descriptive. You can check all of them online if you need to find something specific. There are some more on the right. So index out of range, the one that you probably get. We have no reference. We have out of memory. We have a lot more. So if you want to get out of memory exception, make a string builder demo like the one that I did, but instead of 1 million characters, make them a lot more, or instead of just characters, just put words, and sooner or later you will run out of memory and you will get this this exception. Stack Overflow exception, let me just show that here. So very briefly, because I don't want to get into it too much. So static void method, it's a very bad name for a method, but I know. So if here I code the same method, what's gonna happen? So I enter this method and then goes here, goes on the next line, then I have to call that again, then goes back in, goes back in here, and then executes this, goes back, and so on. And so what happens here? We have the stack, which records all of the method calls that you have. So in the stack here that we saw, right? This is how we call our methods. So here I'm gonna get method, and so on infinitely many times, and you actually have a limit for that, and you get Stack Overflow exception because you get more than the one that you're allowed to use for the stack, which I think was, how much was it? Was it 80 megabytes or something for all of the variables and reference type? It was something like that. So once you go over that, you get this error, which is Stack Overflow exception. So if I call this method now, somewhere up here, I'm just gonna get this error. Please. Okay. Right. There we go. It's funny thing when you search for Stack Overflow exception on Stack Overflow. It's it can be a bit hard to find what exactly happens. So this is called recursion, and it's very useful for some more mathematically defined problems. But we won't go into that until very late in the course. It's not that complicated. It's just you have to see a couple of examples and it'll be fine. Right. So let me just delete that and that as well. Okay. So right. I have demo here and actually have no idea what to show. Oh yeah, I remembered. Okay, it was about the message and so on. So here, let's pick this. If I put some letters instead of a number, so format exception, I can actually give it a name. Okay, it doesn't have to be anyone. I want to store all of the information of the exception here, and I can use this ex, which comes from exception. I can use it here, and I can say console.writeLine ex dot, and let's see what we have here. So we have data, we have, those are just standard methods. We have the message, we have to string, we have source, we have stack trace, and so on. So you can have a look at those, and we have also the inner exception, which if I generate and if I press dot, I'll have the same things, right? Because it's just still an exception. So yeah, right. But the only thing that I want to see now is let's say message. Let's see what that is, and I'll just put a couple of new lines before and after so that we can see properly what's going on, and in here as well. So yeah, let's see what the message is, and I actually have to put in some letters here. Okay, the input string was not in the correct format, so this is the message that we get. And if I want to have this as the stack trace, it gives you the whole trace of which method calls which, and so on, where did the errors appear, and so on. So CS line 46, 14, all of the methods that we have. So read input, I don't know if you see there, let me just zoom in slightly. So read input method in the main, and before that, or maybe, oh yeah, we're not using the division by 0, so yeah, it's just those two, and it tells you exactly where and what this error is. I would like to say that the stack trace is not normally displayed to users, because if I do this now, let me just do the same thing. Here is a very good description of how your logic and classes and methods work, which one calls which, and so on. So you can give some information that shouldn't be out there. Maybe how is your structure of your banking system or your game, and so on, how you arrange the classes, because actually, if so Dota is my game, if you don't know that. So if I get an error and I see the stack trace, and I see which method, which class, what calls what, and so on, I would have a very, very good idea of the architecture of the whole application. And this is not good, because they want to hide all of this information. So this is only for your own use, if you want to have it. Yeah, normally you just display the message so that the user can see it and you can see it also. And if you actually have to see more, which line is it, which method calls which, and so on, then you can change that to stack trace whenever you want, pretty much. So yeah. So this is my text. This is after the catch blocks, and this is in the finally block, which is always executed. Okay, right, let's go on. Okay, exceptions are thrown by the throw keyword. When an exception is thrown, the program execution stops. So the same thing. So once I input, divide by 0, or try to parse a text into int, someone in the code of C# and so on, they said throw this the exception with this text, and yeah, so this is what we are gonna do now. You can throw your own exceptions, and you can choose when exactly that should happen. Okay, so I wanted to say this. So the exception travels over the whole stack to find a catch block, and this is very, very good, because I can handle the error in my main method, and it could appear from some class which is totally out of reach at this point. So the stack is gonna look for this error. It's gonna look for a catch block to handle it, so that your game doesn't stop and your application doesn't stop. So okay, and if it's handled, you will get the error message as well. Okay, so let's see how that is done. So .NET CLR, and this is what executes your programs in C# and other languages as well under Visual Studio. So yeah, so we go to the main. Okay, we have method 1, which calls method 2, which calls method n, whatever. Then we get an exception. Someone throws it, or we get it somewhere. Then we actually go back to the stack, and we try to find some method that handles it back. So method n, find a handler, we didn't find it. Method 2, we didn't find it as well. Method 1, and so on until we get to the main. And if it's not handled there, we will get this error message that normally you see appear quite often in Windows and so on. This means that someone didn't do their job properly. So if you get an error like this and it's like the whole thing stops or freezes and so on, that means that someone didn't do it properly. Okay, so let's throw some exceptions then. Add, I didn't have to do it here, so add new project. Are we gonna get an exception for trying to add a new project? I don't know. What happened, sir? Alright, let me stop the video here. Okay. Alright, so someone didn't do their job and we got an exception, and this happens. So yeah, it's a bit unfortunate that I was talking about exceptions and it happened in Visual Studio. So yeah, it happens. It could be something from Windows 10, which is still in beta, so let's not be too harsh. Alright, so we want to throw exceptions for the person that was sleeping, so throw exceptions, and this is my demo here. Okay, so this is gonna be a bit longer of a demo, and we are gonna have bunnies as well here. So yeah, I would like to say that normally we don't use exceptions this way, but this is just to show you how it's done. And after that, once we know a bit more about object-oriented programming, then we'll use it properly there. For now, I'm just showing you how to do this, and after that we'll see when and where you have to actually do this. So let's say here, throwing exceptions. And yeah, so let's have a bunny. All good demos start with a bunny, but this is gonna be a special bunny. It's gonna be a spider bunny. So struct spider bunny, and I would like my spider bunny to have public int number of legs, and maybe before that public string name. And this has to be with a capital letter because it's a property. Alright, so let's create a new spider bunny. So spider bunny, my bunny equals new spider bunny. Okay, so the idea of this demo is I want to create bunny or a spider bunny with some specific properties. Okay, I don't want to be able to give the bunny 3 legs or 2 legs or -5 legs, and also I don't want to give it a very short name, maybe less than 2 symbols or something like that, or no as well. And as soon as this happens, we are gonna throw a specific exception which is gonna let everyone know that you cannot do that. Okay, so let's start with a try block, and again this creates quite a lot of code for you. So let's do that here. So okay, console write line, and we want to input number of legs. Okay, maybe remove that line. Okay, and I want to have int number of legs equals int.parse console.readline. Okay. What else do I want to have? Okay, so if number of legs is less than 4 and number of legs less than 4, yeah, and number of legs is bigger than or equal to 0, I want to throw an exception in this, specific case where we have 0, 1, 2, or 3. And okay, so here instead of just, so if this was in a method, I could say return new string and say error, you cannot do that, and so on. But as we said, this is not a good way, and it's not a very good way to manage it as well, because it doesn't give us any useful information on the stack and so on. Okay, so instead of doing that, I would like to say throw new. And what do you say? What kind of exception would you like us to throw here? What do you think is suitable if we don't put the right number of the bunny legs?
Please don't make zombie bunnies.
No, this is the text, but I want to have a specific error which is out of range. So argument, and here we have it, argument out of range exception, and I can actually give it a text here. So let's put something funny. Poor bunny, you are a mean person for trying to create a bunny with 3 legs, but it's a spider bunny, so if you see it, then probably you're not gonna be very happy. Okay, so let's say, what else? If number of legs is less than 0, we would like to throw again the same error but with a different text. So throw new argument out of range exception, and I want to say here has the number of legs the number has to be a positive number. Right. Yes, am I forgetting something? Sorry?
You can't have a bunny with 4 legs.
I can't have. Why?
You say less than 4.
Yes.
Equals true.
So if the legs are 0, 1, 2, or 3, only then I want to throw this error. If they're less than 0, then just throw another error. And yeah, okay. What else do we need to do? So once we've done all of that, only then I can say, so once I've validated the number of legs, only then I can say my bunny dot number of legs equals number of legs. Okay, right? Otherwise, I wouldn't be able to start the game and run it with a bunny which has only two legs, right? It's not gonna be fun. So if this error doesn't happen and this error doesn't happen, only then I want to do that. Okay, so this is normally how you throw exceptions, and right now if I try to put something like, so let me just remove that for a second. Is that gonna work without the catch exception? No. So let me just put some division by 0. I just don't want to get inside here, so yeah, okay. So the idea is that now if I run it and I say maybe 2, I forgot to do something, didn't I? Yeah. So I will go here, properties, and current selection, apply. Right, and I was in the first one, and I have to change that as well. So throw exceptions. Right, so let me run that and let's do that again. So if I want to put I have no idea why it does that. So if I want to put 2 now, okay, I am gonna get the exception, and somewhere around here, parameter name is gonna say, poor bunny, you are a mean person. You are a mean person. Has to be there. Did I press insert? Yeah. Let me just put that again. Okay, and this is the the message that we get. So it's gonna be very clear what's happened, why you're not allowed to do that. Well, not with this text, but normally if I add something like more than 4 legs, please, then now it's gonna be clear, right? Put 2. Okay, let's put something else. Let's put minus, I don't know, minus 7, and we get the other value, which is the number of legs has to be a positive number. Okay, right. So why do I have this catch? Well, maybe these are the places where I want to throw an error, and these are the places where I want to catch errors. Okay, so in this demo, I am doing both. So I wanna catch the same errors that I had for the in.parse. I wanna have what was it, out of what were the 2 exceptions that I want to handle for the in.parse? So one was FormatException. So number of legs should be an integer. Maybe I want to catch something else. So here I want to catch, what was the other overflow exception? Not so many legs, please. Right. Okay, and let's semicolon. Yeah, it's gonna happen every now and then. Okay, and right. So now everything is fine. What I want to do next is do pretty much the same thing for the bunny, but just don't do it in a try catch block. So let's do that as well. So console write line input spider bunny name. Okay, and again remove the line here. Alright, and I want to say string name equals console.readLine. Can I get the exceptions here when I read the string? Maybe, but I don't think so. No, I think it's fine. So this right here, I don't need to have a try catch block because I actually don't want to catch any errors when I do this operation, console.readLine, because I'm not parsing anything. Okay, and I want to do the same thing. So if name.length is less than 2, let's throw new argument out of range exception, and it's gonna have text. The spider bunny should have a name with more than 2 characters. Right, and let's do another one just so that we see another type of exception. So if what was it, string is null or empty, or null or white space, let's do that. We want to throw again the same one. So yeah, but here I have to specify name, right? Name. Throw argument out of range exception. Yes. Okay, and inside here I want to say please don't leave the spider bunny without a name. Alright, and once I've done all of that and all of the code is executed and so on, we don't get any exceptions and so on. Finally, I can say my bunny.name equals equals name. Okay, and let's try to print that as well. And here I want to say the bunny has this many legs and is called. Sorry, I didn't say the number. I did it up here. So this is a good thing to notice, that if I actually take this and try to do it here, it's gonna say that it doesn't find this variable, okay? Because everything that's in the try block is like in a separate method. Not really, but everything that I initialize here, it can only be used there, and that's kind of the point of the try block. So let me just put that back there, which was down here. Thank you. And yeah, so let's do my bunny dot name dot number of legs, and my bunny dot name. Okay, let's see what we've done. Alright, so actually let's make a real bunny this time. So make it a 4 and put some random name, and the bunny has 4 legs, has 4, amazing, has 4 legs, and is called, okay, the bunny has 5 legs and is called whatever. The spider bunny, okay, the spider bunny has, it's very weird to do a demo like this, because I want to use the bunny, but again, variable number of legs is kind of bad. So yeah, okay. So let's make a deliberate error here. So let me put that, and put some name. Okay, so now this has the default value, because we are not, the program still executes, because we didn't actually want to stop it straight away. It has some default value, and it keeps running fine. Yeah, this was pretty much it. This is how you throw exceptions. This is how you catch exceptions. This is a very good example of all of that. Notice that I didn't get the, did I get the error? I didn't. So if I put 2, yeah, if I put 2, now it stops, and now it cannot execute because I didn't catch the argument out of range exception. I can do that down here as well if I need to, but I wanted to show just how to throw them and what happens if you do that. So any questions here?
But if we get an exception and we want the user to input a new number.
Okay, so again, the question is, what happens if the user inputs something wrong and we want him to input it again? Normally, exceptions are not used for user input. Okay. The only reason that I'm doing it here, I just want to show you how to do that with a very simple example, which is with the in.parse. Or I can do double dot parse and so on, but the idea is just to show you this is an exception, this is how you try catch it, this is how you throw it. Okay, we're going to be using exceptions in one of the next lectures, and it'll be very clear where you have to use it. You don't use it normally for user input because it's slow, and we'll see why in a second. Okay, any other questions? That was a good question, even though I answered it half an hour ago. No? Sleepy guy? No questions, everything is fine. Okay, let's keep on going. Okay, best practices, and okay, so choose a proper exception type. Okay, this is one of them. So if there isn't, a proper one, make one yourself. But it has to be descriptive. It has to be of what happens. So argument exceptions, argument null exception, like the one that we caught, argument out of range exception, and so on. Okay, so not supported is thrown when some feature is not supported by the application, so that the users can see that it's not supported or it's not working now. And you will tell me where this exception is used, because I'm sure that you've seen it many times. Abstract methods. Methods and abstract classes. Yeah, you can get it anywhere. So if I mean anywhere in those too. But yeah, so you should have seen it by now, because people haven't seen an abstract class. You should have seen it in methods. So if I want to do something like come on and enter some random methods to show exception. Okay, and if I press now Control dot and generate method, and it says not implemented exception, and it's exactly what we just did, right? So throw new not implemented exception, which means that you have to go back and implement this. So this is very useful, especially when you make abstract classes or interfaces and you inherit from those. You will get for every single method not implemented exception, not implemented exception, and so on. And once you start coding and typing and filling in your your part of the code, and you get this error, you will know exactly where to go and where to implement what you need to implement in your game or application. So yeah, this is something that you should probably see quite often, and just means that you have to go back and do the work that is needed to be done there. Nothing that special. Okay, if there is no suitable standard exception, there are a lot, so please search for them. I'm sure that you will find one that you like. If you don't, create your own exception class, which is, again, very easy. Right. Okay, best practices number 2. So catch blocks should be ordered by the exception hierarchy, starting with the lowest and move on to the more general exceptions. And I wanna just write here, but I don't wanna make a new project, so I'll just do new item, and I'll say class question to the audience. Okay, let's just put a method here. So static void method, because I don't have main. Okay, and inside here, what do I want to do? So try int.parse of blah blah, maybe. That should work. Okay, so yeah. So after that, let's say that we do the catch blocks as well. So catch, I want to say exception. I want to say some random exception or some generic exception. And after that, I want to catch FormatException. Write something here. I want to catch overflow exception and write something in here as well. Okay, so the question to the audience, I don't know why. Okay, I know why it's in red, but yeah. Okay, so what's the problem here? And it already did it for you, but I still want to ask the question. So what's the problem here? Okay, so what's gonna happen that I am gonna catch this exception, and these two are unreachable codes. Okay, there is, so in methods as well, you may have gotten this error. So who has gotten this error? Unreachable code with ifs, probably. Yeah, so this is the same thing. Okay, I catch every single error here, and now and I handle it, and after that I catch some other ones which if I've caught the first one, then the other ones are not relevant and they are not going to be executed, these lines of code. So always follow the hierarchy. If you have to look it up online and so on, this thing should be last, and now it is gonna work. Yeah, let me just leave it as is. Okay, interesting. Is it gonna run now? Yeah, is this gonna run now? Should. No, it doesn't, so I'll have to change it still. And I copied it, so let me just delete that. And now it should work. Okay, it's fine. Let's get back here into the presentation. Okay, so from the lowest and move to the more general ones. Each catch block should handle only the exceptions which it expects. Okay, so if you have argument out of range exception, you shouldn't handle format exception in there and so on. Give meaningful text, and don't overdo it with many exceptions that cannot arise at all. Okay, handling all exceptions disregarding their type is a popular bad practice. So normally what many people do, and you would see it in some applications and codes, if you copy from the internet, people will just say just catch, or just catch exception, and handle everything there, which is not meaningful and not useful at all. Because who is this information for? Okay, the user, he will get some generic random error. He will know what that is. If you're the developer and you get this error, it's gonna be the same thing, right? You're not gonna know what's happened, which actually parameter is wrong or something else. You would just not know what's happened and where did that happen. So yeah, just handle the exceptions in hierarchical, I don't know, order. Okay. Okay, a bit more. So when throwing an exception, always pass a good message. So bad examples are unexpected error, invalid argument, something broke, or something happened, something like this. Is very non-descriptive, and it's quite bad for someone to read this. It's pretty much the same, a little bit worse than error 503. Right? What is that? No one knows. But yeah. Okay, good examples. Bunny legs should be more than 4. Passwords should be more than 10 symbols, and so on. Just something descriptive that you are gonna know what is required and so on. Okay, so something that I've mentioned: exceptions decrease the performance. So can you tell me why is the reason for this? Can you guess? Yes. It goes back through the stack to check where actually these exceptions appeared. So you have to go through every single method that you use, every single class that you use, and so on. And this takes time, especially if you have a couple of recursions, methods within methods, a couple of classes which call each other, and so on. The stack can be very big, and it can get very big quite quickly. So yeah.
Yeah, but if you don't handle them, you won't care very much about performance.
Yes, but that's the reason why you handle errors normally for yourself and not for the user. So yeah, I mentioned a couple of times now that that you don't do exception handling for user input. You do it, so the way we're gonna do it is when we create a bunny, and it's not, the proper type of bunny. When I say new bunny of, this and this is not what the user inputs. It's what I actually input and what I actually wanna create. Then it's fine to have it, right? Because the information is for me only. So this is what we are gonna be using the exceptions for. We are gonna be validating the properties so that we can instantiate the objects, and in this case bunnies properly, so that we don't get errors after that in our game. This is the idea of exceptions to my knowledge. Okay, throw exceptions only in situations which should be handled. Okay, so don't just throw here, throw an error there, and so on. Just try to throw exceptions and then handle them, because otherwise your application is gonna stop. Do not throw exceptions in the normal control flow. This is user input, as I said a couple of times. Okay, remember that the CLR could throw exceptions at any time of executing your program, and you should be careful when you should handle those that appear when you're testing. Okay. Homework, since you don't have homework for this lecture, and you're not gonna spend too much time learning this, because it's not that complicated and we only use a couple of things from it. You have the 2048 game to be done as you like. You can do it in monogame, you can do it as a console application, you can do it however you want. Just write it in C#. Yeah, references and questions. Questions? Nope. Okay.